Hi everyone, I'm going to present you real-time emulation methodologies for centralized radio access networks on top of OpenAirInterface 5G. Our configuration is composed of three computers for the radio cloud center, the remote radio unit and the evolved packet core. The network segments for the backhaul and the fronthaul are shown in the figure. Those are the computers I'm using for the emulation in OpenAirInterface. First, we will focus on the evolved packet core. We run the home subscriber server. Next, we run the serving and packet data network gateways. Finally, we run the mobility management entity. As you can see, there is neither connected init bits nor attached UEs. Next, we will move to the remote radio unit. We load the OAI-env script to load OpenAirInterface environment variables. Then we run the script init-nest s1 to enable the IP allocation for UEs. Inside the OAI-sim folder, we execute OAI-sim with 5 arguments. The first one corresponds to the configuration file, the second one to the Gaussian multipath channel, the third one to the visualizer tool called xforms, the fourth one to the number of subframes, in our case 500, and finally the last one to the OpenAir profiler in order to measure the average computation time of software functions related to the multipath channel. We saw the OAI synth xforms. In the end, we create uplink traffic by using the ping function towards the EPC. At this point, the RRU is waiting for the RCC to start. Let's go now to the RCC. We previously compiled the lte-softmodem tool to run the RCC with the tte-tracer. So we need to go to the tte-tracer folder and run the init-bit tool. The tte-tracer tool is launched. We move it to the right side on the screen to visualize the operation of the lte-softmodem in the left side. We ran lte-softmodem with tte-tracer to execute the RCC. So let's see what happens. The first emulation we will run is in the time domain. Everything in the cellular network is running perfectly using general-purpose computers. At the beginning, the RRU is showing spikes of the uplink traffic we started previously using ping. The tte-tracer at the RCC is working, as well as the EPC. We use the eperf tool to create downlink UDP traffic from the EPC to the UE. At this moment we are testing the emulator with both uplink and downlink traffic. At the EPC we saw there is one connected init and one attached UE. You can observe also in the tte-tracer tool everything is organized by modules such as the PDCP, the LC, the MAC, and the physical layer. Finally, the emulation reached 500 subframes, so it stops and shows the average computation time. If we go to the uplink and downlink channels, we notice a computation time of 562 microseconds and 637 microseconds respectively in the time domain. The last emulation we will run is in the frequency domain. Again, everything in a cellular network is running perfectly. At the beginning, the RRU is showing spikes of the uplink traffic in regards with the ping. At the EPC, we see there is one connected eNodeB and one attached UE. We create the downlink UDP traffic from the EPC to the UE using iPerf. At the RRU, the X forms then depicts the constellation of the PDSCH with the traffic and presents the information in the frequency domain, but one order of magnitude faster compared to the time domain. At the end of the frequency domain emulation, after reaching 500 subframes, we observe the OpenAir profiler and notice there is an average computation time of 55 microseconds and 86 microseconds for uplink and downlink multipath channels, respectively. If we sum them, it is clear that we have a real-time emulation.